In the next 4 problems, we're going to actually be sketching some periodic functions. And so using what we know about the repetitions, we can sort of create the future periods of a function. So on question 7, we're given one period, and we're asked to then create a cycle before and after the period we're shown. So the first thing I like to do is sort of go through and figure out what the period is. So in this case, it ends here at 6 and it started at 0. So that gives me a period of 6. And so I can sort of go in, and if it helps you a little, you can know, okay, if the next period is going to be then from 6 until 12. And the period before that would go from 0 to -6. And so I can sort of use that notion of repetition to sort of mark off on my grid where I need to go. The next thing I like to do is I'm going to actually put some points in place. So I know that at the beginning we started low. And yeah, there's technically would sort of be if this was truly to stay a function, one of these would have to be filled in and one of these would have to be open. We weren't given those sorts of details, but I'm just going to generally sort of sketch this in. So we know we start low at our period, and at the end we're going to end up high. And so that's going to be the same thing here. It's low, and then it's going to end up at the high point. And then I like to sort of, I can sort of mark a few more points in there because, I have this line segment right here, and that has a slope, it's traveling at a rate, where it travels up, sort of 1, 2, 3, 4, 5 of these squares and over 2 squares. So I can do sort of the same thing, 1, 2, 3, 4, 5, and then over 2, and I'm going to have a point there. We're then constant for 2 squares over. It goes up 2, and so all I'm doing here is sort of making little notes where I sort of notice the points would be. And then I would just go through and quickly connect the dots. And again, this is a sketch, so it doesn't have to be perfect. But, generally that would be the pattern, and, it would keep going if I wanted to keep, repeating afterwards. And we can do the same thing over here to get us, the one that follows. And again, I like to use my sort of line tool. I'm going to connect. And you'll notice, okay, it should follow that sort of same increasing constant, increasing steep increase, pattern again and again and again. That same idea carries over into the table. In fact, the table is even a little more straightforward. Here, basically, it goes, the outputs go -1, 8, 1, -7, 12. To be periodic then, if this is one period worth, then it's just going to repeat again. So -1, 8, 1, -7, -12. Same idea working backwards, -1, then the problem before that was -12, -7, 1, 8, -1. And so I can sort of see my sort of periods here. I've got my 3 periods. And then the x values here, if you'll notice, each time they're increasing by 3. And so I'm just going to keep that pattern going. So 15 increased by 3 would put me at 18. Then 21, 24, 27, and 30. And then if I'm working backwards, instead of increasing by 3, the inputs are going to decrease by 3 and sort of work into those negative numbers until we get back to the end of our period. And we'll notice, okay, this function has a period of 12 units. This period was 6, this period was 12. It's pretty straightforward when we're given the period, the sort of what the function looks like. What gets a little trickier on the next 2 problems, we're just given some general descriptions about rates of change and then asked to, from there, create what this periodic function might look like. So in this particular case, we're told it's increasing at an increasing rate. And just so that you can sort of remember what that looks like, that would be a concave up graph. Decreasing at a constant rate means we got a line going on. Constant means we have a horizontal line, and increasing at a decreasing rate would actually be concave down. So I'm sort of giving myself some hints about what those shapes of the graphs would look like. And then on top of that, we're given the minimum value and the maximum value. So I'm actually going to start with those. And so what I like to do is I'm going to create some guides on my graph to sort of help me know where I need to put stuff. And then I'll fill in, my lines as needed. So I know -2 is the lowest point on my graph, and I know that 10 is the highest point. And I like filling in those values because I know everything should fall between those points. It's a periodic function. It's going to repeat. We're never going to get above and we're never going to get below that. On a similar way, I then also sort of like to create the structures between the x values that we're given here. So initially we're given from -1 to 2. So this graph, I'll notice that each sort of gray line is counting by ones. So -1 would fall about here, and then 2 would put us here. And I know between those two lines, we are increasing concave up. And so I just made a little note for myself below. Okay, then we go from 2 to 4. And this time we are decreasing at a constant rate. And then 4 to 5, super teeny spot, we're constant. And then from 5 to 9, we're going to be increasing at a decreasing rate. So something sort of like that. Now, we need to pay attention here that the only time that it's going down is between 2 to 4, which means between those two values, I have to go from my high point to my low point. Because we're told that, I'm going to hit that high point and I'm going to hit the low point. And so I could go through and say, all right, I'm going from, let's get the line tool there. Ta-da, that has to happen. I have to hit my minimum value and I have to hit my maximum value. Now, between 4 and 5, we're constant. And then the next two pieces, I'm increasing at an increasing rate and I'm increasing at a decreasing rate. What might actually help here for you is to sort of take this and not actually draw it where we're given, but think about this continuing on. So this was 3 units here. So the next 3 units following that 9 should be the same as the 3 units back there. So it should be increasing at an increasing rate, which means, if this is repeating, I should end high. This one starts low. And so basically, between these two dotted lines, I'm going to be increasing at a decreasing rate and then increasing at an increasing rate. And so you'll sort of notice I've switched, or I have like a point of inflection right here at 4. And so then the matter is just repeating your process on the other sides of your graph. And so we have 1 period here, and I needed to do at least 2 cycles of your graph. So, you can keep this going, 2 units down to 1 unit over, 1, 2, 3, 4 units, 2, 3, 4. Don't be shy about giving yourself guides to sort of help you figure things out. And then, we could keep going. Technically, I've done my 2 periods. Here is period number 2, but I got a lot of space on my graph, so, maybe I continue it a little further, because why not? And you can sort of keep that pattern repeating again and again and again, and it would keep going. I'm then asked to take my graph and think about what is the period, min, max, midline of this sort of function we created. So here, notice we already sort of marked off where one period fell. And so we could count. It goes from -1 to 9. And so our period here would be 10 units. The minimum value was given to us. It was -2. The maximum value was 10. It was also given to us. And our midline should fall in the middle between that -2 value and that 10 value, which is a distance of 12. So it should be 6 units away from the max or the min, which happens to be at 4. And I intentionally made sort of my point of inflection right here at that midline. Now you can keep the guides in there or take them out depending on if you wanted to sort of clean up your graph a little. It doesn't really matter, the graph. The important part was sort of the black, lines out, curves I was drawing in there. Now on number 10, I'm not going to do this all the way out, but it's going to be similar. We're given some different information to begin with. In this case, we're given some points to start at that we want to make sure that we include on our graph. We're also told that the vertical intercept is the midline. So in this case, we are given that the vertical intercept is 5 right here. And that's also the midline of your graph. So that means this should be the middle of my graph, and it should go above this and below this. We're also told that the horizontal intercepts are the minimum points, and the horizontal intercepts occurred at 5, and there's one at 15. And those are 5 units away from that, that midline. So while 0 is the bottom of my function, 5 units above my midline would put the tallest points at 10. And so I know my graph's going to need to stick between those 2 points. And just like before, we can go through and sort of divide up our graph into those grids and think about decreasing at a constant rate. So we got our linear sort of line there. Decreasing at an increasing rate, that basically means you're getting less negative. So actually, it's going to be a concave up sort of curve like that, while decreasing at a decreasing rate would be concave down, and then increasing at an increasing rate, as we mentioned earlier, would be a concave up graph. So you got to keep sort of some of those concavities straight when you're working through this. Just like before, I'd strongly recommend, you sort of split up your graph into curves, or sort of not curves, segments, just to make it a little easier to sort of figure out where things need to go. And so I'm just sort of going through and drawing in lines at each of these. So I have one at -2, then 0, then 2.5, then the next one's at 5. Then we go over from 5 to 8. And that's it. And then it would repeat again. Now, you got to think mins and maxes. We know we're at our midline here. We know we're at our min here. We're decreasing, increasing here at the end. So knowing that in this last unit is the only part of the graph we're increasing from, I do know that I'm going from this low point all the way up to the high point here. And it needs to be, increasing at an increasing rate. So if you can get it, you want it to be slightly concave up there. Between 2.5 and 5, we're concave down and decreasing. Oops, but I probably made that too much. Too much. We need to go from I'm actually going to work a little backwards here. So, sorry, I'm going to try a different direction. So if I'm decreasing at a constant rate, I know my period ends at the high point. So I'm going to start at my high point, decrease at a constant rate. Now I am decreasing at an increasing rate. And then I'm going to switch to decreasing at a decrease. So decreasing at an increasing rate, decreasing at a decreasing rate, then back to increasing at an increasing rate. Whew. Same idea over here. So constant for 2 units. then we are decreasing at an increasing rate from 0 to 2.5. So 2.5 would be about here. And we want to make sure, we want to try and get this, as sort of lined up as possible when we're sort of working through our little graph. And then 3 units gets us back. It doesn't have to be perfect, and we could keep going. So the period this time again would be one of these sort of paths between the 5 and 15. So it was a period of 10 again. We already talked about our max was at 10. Our min this time was at 0. And so our midline, which we were given, fell at y equals 5. And hopefully that gives you sort of a sense of how to sort of sketch these periodic functions from information that we're given.